Hi, and welcome to DCO. In this video, I'll be going over all of the steps that are necessary for creating these sets of stairs. Now, the cool thing about this is that this has some nosing, so that detail is included, and also creating a landing with an additional set of stairs. Now, I've created the same set at the beginning and at the end, but following some of the similar steps, you can actually change which tread or how many you're going to have here at the top and at the bottom, and you can vary them, have multiple landings. So I won't be going over that, but I'll be going over the general steps for creating this. So let's go over those. If you want to gain access to the script that I created in this video, join the Script Vault membership where you'll have access to the script and much more. Otherwise, keep an eye out on the script store where I will have the optimized version of the script so you can download it there. I post videos like this every week, so make sure to subscribe so you don't miss any updates. Thank you very much for being here. Hit the like button if you enjoy this tutorial, and let's jump right in. Hey, I hope you're having a wonderful day. Let's get started creating this design. So we'll start by creating a bearing and file, and in here I'll go to units, making sure that my units are in inches, because the design that we're creating today, the base dimensions that I'll be using are going to be in inches, and since that's the case, then I'll use that for my units. So now I'll go here to construct point. Once I've brought this point in, this creates a parametric point at the 0, 0, 0 on the X, Y, and Z coordinate system. Now with this point, what we want to do is bring in another point component and plug that right into it, because this allows us to then change to this point or set a different point if we have, let's say, a location we want to place it on a model. So with this, this is where we start our whole design, and so everything will be based off of a reference point. So when you want to put this somewhere else, all you need is a point. So we'll start here. We'll go to move and move this point in the Z direction. Why? Because this is going to give us the height of our tread. So I'll plug in the point into the geometry and unit Z into the motion. I'll change the factor to a slider that is going to be more than 6 inches, but less than 8. So 6 less than 8.000. This way we have a few decimal points, but this ties us to a specific tread height. Now we can move this in the X direction to create the tread length. Let's go here to move in the X direction. And we'll create a custom slider. We'll go to 11 less than 20. This way we don't go any smaller than 11, we don't go any longer than 20, and we're kind of keeping in mind some of the minimum and maximum so we don't go past those. Now this is just using a regular slider. There are other ways we can achieve this, but with this is basically what we need to create a basic set of stairs. But in my case, I want to create a nosing here because typically that's what you would have on a set of stairs. Now there's different designs for nosings. For me, I'm going to create a square one. So how do we achieve this? Well, what we have to do is take this point, move it in the negative X direction and in the negative Z direction by either the same or a different amount. In this way, we have the points that create that overall form. So we'll go to this point, move, I plugged in transform rather than geometry. Then we're going to go in the X direction. We're going to go negative Now we're going to go negative. So either copy this again or bring in a new one. We're now going to bring that down in the negative z direction. And this slider will give us our nosing. So we'll go 0.5 less than 2.000. Call this nosing X. And call the next one and not only do we need to bring down this point, we also need to bring down this point. So I'll take this, and we want each point to be its own separate output. So I'll copy this down, holding down Alt, and then bring over geometry from this one. We have all of these as a separate output. This way, now all we need to do is connect the points here. So depending on if we want a fillet edge or a rounded edge here or down here, those details would also be worked out before we create that entire array. So I guess starting from the basics, we'll just create the polyline that creates that tread. Let's go here to polyline, start with our polyline component, and let's start with the first point, which is going to be our base and inserted point. Going to be this one. Plug that into the vertices. One of the things I like to do, and sometimes I forget to do it, but keeping everything in mind here, I like to double click here and make sure that I know I'm going to plug in more than one point into this input. I'd rather just do them all into this one. So we'll go here. We start here, then we move this. We actually want this one. And progressively, we'll highlight and turn green the one that we want next. Holding down Shift, we'll bring that in. And technically on this one, we don't need it because we can go all the way to the last one. We can always add that input if we want to. We're just showing you. Now with this, let's create the continuation of the treads by creating an array and some copies. So here at the beginning, I'll have this polyline. And so we'll go here to move this polyline. In which direction? In the X direction. But as you can see, it only copies one, and we want more than one. So we want a series. We'll bring in the series component. Count how many. So we'll go to 5. Step is going to be the same amount as the overall length. So we'll go here to nosing. And I'll start labeling these. Tread height, tread length. And so the tread length is the number we want to use. And with this, we should have here over the output 5 different numbers that jump every 11 numbers. So let's go here to the factor. So we've created 5 treads in the X direction. And then we'll do the same thing, but in the Y direction. But rather than having the step be the length, we're going to have it be the height. This is going to be Z, actually, unit Z. Now we have 5 values. Here we have 5 values coming in, and those will become the 5 values for the treads. So we have, and there's a simpler way of doing this, but I like to show the 2 different directions in which the treads are created. And here I'll go number of treads. I'll disable the preview on all of this stuff back here, including the points. And let's go here to extrude and bring in Y. So unit Y. And then 36. We'll do 42 inches. So what I'm doing is I'm extruding it just to show you what it looks like here when we have that set. And the cool thing is we can adjust the height, the length, like this. If this were like a landscape, you make them a little bit taller, maybe a little bit shorter, but a little bit longer. And then nosing was we don't want to go too far, like 2 inches, that's too much. I would say 1 inch max. And nosing down, well, you can play with that. I think that could create a cool effect. You go further with that. So, and here, if we don't like the way that looks and you want it to have a rounded edge, we can fill it edge here using 0.125, which is a 1/4 inch, and then use this right, like it'll do the maximum until it can't do more, and then it'll continue on the ones where it can. So I guess in some of what I'd like to explain here is if we look at it in elevation view, I think it'll make way more sense, is that before we rounded it off, this is some of the things that Grasshopper already kind of does. Oh shoot, I guess this is the extrusion. Some of the things that Grasshopper already does by default is if you are to round this off, it'll do them all the same. But as you can see here, you're going to have the center of the split between these 2 lines. There's going to be a line segment. The length of that divided by 2 is going to be the maximum radius that you can have for this and this. And if you're going to go for this one, well, is going to be the distance between half of that and anything left over for the length of this segment, you can turn that into a radius. So you can see that if we have a maximum radius of say 5, you can probably go fairly kind of far like this, and it kind of creates a cool effect. It depends on what you're trying to go for, but for the most part you just want like a 1/2" round off, and they do that during construction with their tools. So with this, now I want to show how to create a landing so then you can create more copies of this, because this is fairly straightforward to create. But what I've thought about is, what if you want to have 5 treads, then a landing, then another 5 treads, then a landing, or 2 treads, then a landing, then 5 treads. And I mean, you can, just by knowing that you can create 2 sets, you can obviously create an infinite amount. And you don't want to create an infinite amount in reality. You don't want a slider to just create a bunch of them. You want to be specific about what you want with your script. So that's one of the things that I want to teach also, is be mindful of what your end script is going to be, unless you're just trying to exercise and do whatever you want. So this is one of the things that I wanted to do. And so I'm going to show you now how to create a landing and then take that same set of stairs and copy them up there. Now the thing is, I will not be sharing how to create the railings. I've showed how to do that in other locations, and in here, if anything, I'll end up just developing it a little bit once I bake it. So let's go here to our curve, which is this one. Now we have to think about this, that we want another line segment from here to here that creates a landing. Here's the thing. If we are to create a landing and this is 4 feet, well, it would be 4 feet plus, 20 inches if that's whatever the length of this is. So keeping that in mind too, is we have to subtract that overall length. So let's take a look at this and bring in endpoint. I'll go here to endpoints. And I can bring in the endpoints, but it's going to give me actually the endpoints of all of those. Or if I were to try to array this point, it would do the same thing. So thinking here out loud is, I'm going to take this fillet and join curves. So it joins it into one curve. Because if I hover here, it'll say 5, and I want it to say 1. This way, it only gives me the start and end. Now I'll just isolate this using one point, the endpoint. This way I can disable the preview on all of this. And now move this in the X direction. How much? Well, we said the landing was going to be 48. What happens is 48 minus the tread length. So 48, subtraction, number of tread, that's tread length here. And we'll use this 20. So overall, from here to here, you have 48. Even though 48 here, and so if we bring that down to 0, we don't have a tread. We bring it all the way out to 100, we have 100. So we go here to 48, and now we can connect this point and this point. So bring in a line segment between start point and end point. Between A and B, one straight line segment. And technically we can add that to our inputs here. You can see we have our landing. Now the idea would be to join that with this one. We'll go here to join curve. So as we go along, we join the curve and our logic continues. And as long as you make sure to be careful and you've kind of taken the correct steps and you have a bit of experience, you can foresee some things that will work or not. But for the most part, if you have some experience, you'll kind of foresee some of the steps if you've taken them before. If you haven't, then try to build up some of those things using just by exercising using this program. The more you use it, the more you'll be used to it. So with this, we can extrude it, or we can now copy all of these threads up to this endpoint. Now, there are different ways of doing that, but I'm trying to think of what's the most efficient way of doing it. And for me, it's going to be creating a vector. We're going to create from this endpoint to the start point, that vector, and then we're going to move all those threads that same vector. A bit of a weird approach, probably other approaches, but the thing is, they all kind of lead in the same direction. It depends on which one you feel most comfortable with. For me, I can visualize where I want to move things, and I know that all I need is a vector in a direction, in a magnitude, and I can move it into that location. So without talking too much, I'll go back here to curves, go here to endpoint, plug that in, and we have the start and endpoint. That creates a line segment. And a line segment between the start and endpoint creates a magnitude and a direction, which means that I can disable the preview on this first and then move using, rather than a motion, you're going to see that this line is going to be what we move, and what we move is going to be this set here. So we have literally moved this set from this point using this line segment as a magnitude in a direction or a vector to this location, giving us the overall set of stairs. Why? Okay, because we can add more stairs. And when I add more stairs, that magnitude and that vector will add, and so it will always change and everything will be consistent. So we can do a landing that is larger than 35, or this is an extrusion of. And why am I doing this here? Well, because I was just previewing that before. So we'll go here and we'll join it all together using join curves. These two, right click, flatten input. This way it makes sure that it brings all of those as a one list and therefore outputs as one single curve. So let's disable preview and let's plug this in. So what I like to do is show people how to use this program for super useful architectural designs, because people think that this is such a complicated program that, oh, why would I use that program? I can't use it for architecture. It's like, no, you can use it for architecture and you can create some pretty cool designs. This shows you zero landing. The same, this would be matching the tread, and then here is where you would add more. And to be realistic, the maximum treads that you could have are 20. Because, like I said, tying it back to reality and back to architecture is this, technically, you can have 20 treads before you need a landing. And so this is by arraying it once, but we can technically also take these two segments I was going to try to do a rectangle, these two segments, and copy them to create an infinite amount of treads and landing. But with this one, we can technically change what the treads are here. And we can, if we want to, just copy a segment and then have this be a separate amount. Now, I'm not going to do that on this one, but what I will do is show you how to turn this just into a solid. So let's go here. And with this, we are going to close it. So bring this all the way down and then bring this all the way over and finish off this design. So running through my mind, I'm trying to think of what are the different ways of doing this. And I'm going to show you two ways. One is going to be by once again bringing in endpoints. We'll plug in the curve into the input. Now bring this point down this amount. Now what happens is if we wanted to be at the same location as the start and end point, I would here at the start point create an X, Y plane. This is going to create a plane just like this construction plane here at the start point. And now this end point, we're going to project onto a plane. So this plane, we're projecting the end point. So no matter where this ends, it will be projected down to where the start point is, therefore creating 3 points. 1, 2, and then the start point. So let's go here to a polyline. Go from endpoint to projected point to start point. And now we can join the curves. So we'll bring in the join component, plug in curves and curves into the curve input. Flatten the input here and extrude. Now create boundary surface, which means solid there, and then extrude that. How cool is that? You can create a cool set of stairs like this as a solid, and then create the, so like if you were a skateboarder, this would be like a really nice set of stairs. And more development could be, let's see what else could be played with. The overall form is just an extrusion. There is a way to use that surface and then apply it to a different surface to create a curved one, but play around it. And lastly, what I see here is there's this crease, and that's created from that overextension for the landing. So I do tend to go to merge all coplanar faces. As long as we don't have too many, then it won't take too long. Sometimes when you bring this in and you have way too many for it to take care of, it does bog down your script a little bit. And you can see that by going to display, profiler. Here you can tell which component takes longest, and when you extrude or when you do Boolean operations, it takes a lot longer. But since we're just using polylines, surfaces, and extrusions, it won't take too long. So just something else to keep in mind. So from here, I'm just going to develop this and turn this into a few different sets of stairs, then render it and then show that as like an exhibit. But if you'd like to get a hold of this script or a bunch of different scripts that I create for my YouTube videos, check out my website, capettidavid.com. I have a script vault membership where you can check out all these scripts and we can be in touch, so I can help you in any case. So if you have any questions, make sure to let me know. Thank you very much for watching, and check out this little bit, and I hope to see you next time.